Hello, today I'm going to be showing you how to use OrCAD Capture to simulate a circuit. This is going to be a real quick introduction, so basically just follow along if you're looking for a quick guide. We're going to go to New Project here, name this whatever you'd like. I'm going to say Rectifier because I'm going to be making a rectifying circuit. I'm going to start by creating a blank project. Once you see this, this is where we're going to lay out our circuit. If you don't see this, you might need to come down to here, this folder, and open this, and right click and make a new page. If you do see this, you're good to go. First thing we're going to do to place a part is we're going to click on the background and press P, which is the hotkey to place a part. That'll pull up this menu over here. If you don't see a lot of libraries here, you might need to click this button here. Come into here, click on any one of these and do Control A, which will select all of your libraries and it'll load them all into here. We're going to start by placing a ground. So again, I'm going to click on the background, press G, and I'm going to use this O0 capsum one here. You need a ground for your circuit, otherwise current is not going to flow and you're not going to get anything on your output. Okay, next I'm going to add a source. So I just click here again and just type source. And pick whatever type of source you want. I'm going to be using a sinusoidal voltage source. I'll place this here. I'm going to mess with the parameters in a minute. I like to get all my components on the screen first. Next we're going to add a resistor as our load. So I'm going to come here again and type in analog, type R, and here's our resistor. Before you place it, if you want to rotate it, you can press R on your keyboard and that'll rotate the component. Next we need a diode for a rectifying circuit, so I'm going to type in diode here. I'm going to look for the part D1N4148. Useful tip, if you're trying to find a part and you don't know what the part number is, you can go to ChatGPT or Perplexity and type in what type of part you're looking for. Say, what is the part name or number in OrCAD Capture for this, and it'll usually spit out what to do. It's really good for debugging a circuit too. If you just explain what's going wrong, it'll tell you step-by-step instructions of how to fix it. Okay, I don't know why that placed 2 there. Okay, we have everything we need for our circuit. So now we have all of our components here. We're going to wire everything together. We're going to start by pressing, click on the background again, press W. If you want to create a bend in the wire, you can click. That'll keep that part of the wire there. And then click again once you see that red circle pop up. That means you're connected. Connected. Yeah, click down here so it keeps the wire down there. Click. I'm not sure what this red dot is here, so I'm just going to redo this real quick. That's better. And then finally connect our ground. Now we're going to go over here and change the parameters for our voltage source. V off. That moves our sinusoidal signal up and down along the y-axis. V amplitude is the amplitude of the wave. We're going to make that 3. Frequency, let's try 0.1. We could just do 100 hertz. AC, we're going to leave this at 0. Okay.
What do you want?
Whoa. Siri. Next step is to set up a simulation profile. You can name it whatever you'd like. I'm just going to say test. It's not real important. We're going to be doing a
You'll need to unlock your iPhone first.
What are you talking about? We're going to do a transient analysis so we can see how the circuit behaves over time, since this is an AC signal. I like to set this to about 100 milliseconds and do a maximum step size of 100 microseconds. If you make this maximum step size too small, it may take a long time for your circuit to simulate, but I've never really had to wait super long. And these are kind of the parameters that I usually start with when I'm testing out a circuit. So we'll do apply, okay. Next we want to add our probes. You can use a current marker, voltage, voltmeter, whatever you need to see, and just place it across the component that you want to observe. I want to see the voltage across this resistor here, which is the load resistor. So I'm placing those there. And that's it. Now we do run. So you'll see a window pop up here on the bottom. And if everything's connected correctly, we'll see an output like we see here. So if we want to, we can add a trace. So say I want to see the input, this is the output voltage across R1. Say I want to see the input voltage compared to the output voltage. There we go. Just add a trace like that. We can see the output voltage is a little bit lower because that diode usually has a turn on voltage of 0.8, so there's going to be a voltage drop across there. So we can see at the peak the input is 3 volts, and here it's about 2.4. So yeah, about 0.6 is the turn on voltage of the diode, so it looks like everything works correctly. And that's it. Hopefully this video was helpful. Thank you.